Welcome to this explainer. Let's just dive right in, because today we're unpacking a genuinely fascinating report from the World Economic Forum. Every single year, a jury of world-leading experts essentially sifts through all the noise to find the actual, tangible scientific advances that are, well, finally ready to change the world. In this explainer, we're going to walk through their list of the top 10 emerging technologies that are poised to scale up and fundamentally alter our day-to-day lives by the year 2026. But honestly, before we get into the list, we gotta ask ourselves, are we actually ready for 2026? To really grasp how fast our future is shifting, we need to look at the underlying trends driving these innovations. We're moving incredibly fast toward a world of hyper-personalization, hyper-localized production, and this absolutely desperate necessity to do more with less. And to be clear, we aren't just talking about cool concepts stuck in a lab somewhere. These are technologies sitting right on the verge of mainstream adoption. So, instead of a basic, boring countdown, we're going to explore these breakthroughs across 4 massive global shifts. 1. Reshaping our planet's resources. 2. Healing the human body. 3. Next-gen computing and AI. And 4. The new scientific method. Let's start with Section 1, Reshaping our planet's resources, adapting to extreme demands. Starting right here in our physical world, we are facing some pretty intense macro-level challenges. I'm talking about unprecedented sweltering heat waves, massive power grid strains, and the looming reality of needing to feed 9 billion people by 2050 without entirely breaking the planet. Our first technology, everything-to-grid energy, tackles this by completely redefining the stuff we interact with every day. Think about a hot summer afternoon in a massive city. You can practically hear the hum of millions of air conditioners straining the power grid. Traditionally, grid demand is a one-way street, but this tech turns everyday items like your electric vehicle, commercial buildings, or warehouse batteries into smart, bidirectional nodes. They don't just suck up power anymore. They can actually store and send it back to stabilize the grid in real time, actively preventing blackouts. Now, to build the vast amount of batteries needed for a smart grid like that, we need lithium. And currently, getting that lithium largely relies on massive, geometric turquoise evaporation ponds in places like the high-altitude Atacama Desert in Chile. It can literally take up to 2 whole years for the sun to evaporate the water. Direct lithium extraction, or DLE, completely bypasses that wait. It's a modular system that pulls lithium from brine in a matter of mere hours. It uses way less water and doesn't require these highly specific extreme geographic conditions. That means we can potentially start extracting and refining lithium in the exact same location. Speaking of those sweltering summers, 40%. That massive number represents the potential energy savings from our next breakthrough, which is passive radiative cooling materials. You see, cooling a building normally requires electricity, which in turn creates more heat, feeding into this vicious cycle known as the cooling paradox. But imagine a special paint or a roof coating that just cools itself without using a single watt of electricity. These materials are quite literally designed to bypass our atmosphere entirely, beaming heat directly up into deep space. You could drop the temperature of a building below the surrounding air temperature, keeping factories, schools, and our homes perfectly livable while saving up to 40% on energy. Finally, in this section, we have to tackle the challenge of feeding 9 billion people. The math of traditional agriculture just doesn't scale to that level without hitting our planetary limits. Enter precision fermentation. This technology gives simple microbes like yeast brand new biological instructions. We can essentially program these microbes in massive fermentation tanks to brew real food, creating exact identical replicas of proteins or fats. You can literally produce identical cow's whey protein without ever needing the cow. This kind of localized production could secure our fragile food supply chains dramatically. So these 4 innovations vividly showcase a central theme here: doing more with less. By completely rethinking how we harness energy, mine minerals, cool our spaces, and brew our food, we really can secure our planet's resources in an increasingly demanding world. Let's move on to Section 2, Healing the Human Body, from forever chemicals to custom cures. Shifting from the macro level of the entire planet all the way down to the microscopic, we kick off with a massive environmental health breakthrough: PFAS destruction. PFAS are the materials that make pans nonstick or firefighting foam work. They're commonly known as forever chemicals because they are built on the carbon-fluorine bond, which is literally one of the strongest bonds in organic chemistry. They simply do not biodegrade. We find them up in the Arctic, in rainwater, and even in the bloodstreams of almost everyone tested. But now, scientists have actually found ways to finally break that unbreakable bond using techniques like specialized electrodes.
This means we don't just have to contain contaminated water and land anymore. We can actually completely destroy the forever chemicals and clean it all up for good. Moving inside the human body, our next breakthrough is exosome drug delivery. An exosome is basically a tiny membrane packet. It's like a natural courier service that your cells use to communicate with each other. For decades, getting medicines to specific parts of the body has been incredibly tough because our body treats them as foreign invaders and blocks them. The blood-brain barrier is a perfect example of this. But by loading drugs into a patient's own natural exosomes, the body recognizes the courier and just lets it right in. This is unlocking entirely new, game-changing pathways for treating devastating neurological diseases like Alzheimer's and Parkinson's. Our next medical breakthrough addresses a pretty brutal reality. Treating cancer with traditional chemotherapy is very often described as cracking a walnut with a sledgehammer. It causes massive collateral damage because, at its core, it's largely a population average treatment. But this new era brings us personalized mRNA cancer vaccines. A doctor can take a biopsy of a totally unique tumor, sequence its specific mutations, and custom build an mRNA vaccine to attack that exact cancer for that exact patient in just a matter of weeks. The science is honestly miraculous, though scaling it definitely remains a global health challenge right now, since early treatments can exceed $100,000. Now, to make drug discovery cheaper and faster across the board, we have to fix a staggering statistic. 9 out of 10 drug candidates fail their clinical trials. Why? Because traditionally, computers are just approximating how molecules behave. But with quantum simulation, we are leveraging the actual laws of physics. Quantum computers can model how a potential drug molecule folds and locks into its target atom by atom with absolute precision before a physical version ever even reaches a lab. By getting it right digitally first, we vastly improve the odds of success in the real world, fundamentally changing the economics of treating rare diseases. These 4 medical and environmental breakthroughs highlight a monumental shift. We are moving entirely away from broad, one-size-fits-all, sledgehammer approaches and toward hyper-personalized, localized, and microscopic precision that heals us from the inside out. All right, Section 3, Next-Gen Computing and AI, the Cognitive Frontier. Stepping into the digital realm, we really need to understand the difference in how artificial intelligence is starting to learn. Traditional large language models learn from massive amounts of text, essentially human descriptions of the world. But human knowledge isn't just words, right? Think about a baby in a high chair dropping a spoon onto the floor. That baby doesn't know the word gravity, but they feel the weight, they see it fall, and they hear the thud. They're actively building a mental model of physics through physical experience. The new AI breakthrough, called world models, mimics exactly this. By ingesting video, depth sensors, and motion capture, these AI models actually learn spatial and physical context. This allows robots on factory floors or even advanced climate models to intuitively adapt to unpredictable real-world situations, rather than just following rigid, pre-written scripts. But as AI and computing get more powerful, our security has to evolve right alongside them. We're currently facing a very real threat known as harvest now, decrypt later, where criminals steal encrypted data today, just waiting for future quantum computers powerful enough to crack it open. Enter lattice-based cryptography. This technology hides your sensitive data inside a multi-dimensional mathematical fog. It's so complex that even a super-powered quantum computer just gets lost in the noise. This allows for incredible new uses of data. For example, hospitals can safely combine and train AI on hundreds of thousands of patient records, all because the actual data remains perfectly hidden within that mathematical fog. Together, world models and lattice-based cryptography represent the absolute cutting edge of our digital leap. We are building machines that finally grasp the real physical context of the world while simultaneously ensuring that our private, digital lives remain permanently secure against future threats. And finally, Section 4, the new scientific method and how innovation actually scales. As we step back and look across all 10 of these incredible technologies, we are witnessing something profound, a total inversion of the scientific method itself. Traditionally, a scientist forms a hypothesis first and then runs a highly targeted experiment to test it. But with AI's ability to compress timelines and analyze vast oceans of data, AI-driven science does the exact opposite. Researchers can now ask incredibly broad, open questions and just allow AI to experiment on massive datasets pre-hypothesis. The AI finds the patterns and generates the hypothesis for us. Human validation is now shifting to the very end of the discovery pipeline, forever accelerating how scientific breakthroughs are born.
But of course, an amazing idea sitting in a lab doesn't just automatically change the world. For any of these breakthroughs to truly scale by 2026, three things must happen. First, the core technology pieces have to be ready. For example, mRNA was identified years ago, but it simply couldn't scale until the right delivery mechanism was invented back in 2018. Second, you need high-risk tolerance, someone out there willing to bet on an expensive, unproven early version just because the need is so severe. And third, you need a massive institutional push, whether that's sweeping government regulations to force the cleanup of forever chemicals or immense private sector investment to build out smart grids.
From decentralized neighborhood power grids and self-cooling buildings to AI that intuitively understands gravity and vaccines built specifically for your own unique biology, the future is arriving incredibly fast. We are entering an era that is unequivocally more personalized, more localized, and vastly more efficient. This science is no longer just theoretical. So, knowing all this, the only real question left to ask yourself is, which of these top 10 emerging technologies is going to impact your life first? Thank you so much for joining us on this explainer, and we will see you next time.